Hey guys, Mr. Yisley here. So we are on to our final chapter of the year, chapter 6, which is all about factoring. And factoring is essentially the reverse process of what we just talked about in chapter 5 when we were working on with polynomials and we were doing the FOIL method and all of these things. Factoring is basically the reverse of that. But we'll talk more about it as the chapter goes along and show you how it all works, of course. But first we need to line out a couple of terms that you will see frequently and hear frequently throughout this chapter. And our first term here is factor. And factor is, as it says on your paper, a number that can be written, right? A number that can be multiplied to create a specific product. So for instance, what we're saying is, like if we had the number 6, numbers that could be multiplied, you could multiply 1 by something and get 6. You could even multiply 2 by something and get 6. You could multiply 3 by something and get 6. You can't multiply 4 by anything to get 6. You can't multiply 5 by anything to get 6. But you can multiply 6 by something to get 6. And so factors would be these numbers right here that we've listed out. Those are the numbers that go evenly into 6. They can be multiplied by something to get to the number 6. So that leads us into our second word here, which is factor pairs. So now we're talking about the numbers specifically that can be multiplied together. So this is two numbers that multiply together to make a specific product. So two numbers that multiply together to make a specific product. So for instance, if we're trying to figure out factor pairs of 6, I always say let's start with the first number, which is 1. Okay, what do we multiply 1 by to get to 6? Well, we multiply 1 by 6. Well then, 2, can we multiply 2 by something to get to 6? We can multiply 2 by something, and that something is 3, so 2 times 3 equals 6. And then my next number is 3, which already happens to be in my factor pair list I've started created here. So I know that's all the numbers. And again, if we looked up at the list we created earlier, that's all the whole numbers that can be multiplied together to make the number 6. And so we'll talk more about these lists later on in the chapter and go over all of that here pretty soon. So our last term here that we see is greatest common factor. Also, you might see it referred to as the GCF. And what the GCF is, the greatest common factor, it's the largest factor. So the biggest factor, right, that all terms of an expression have in common. So it's the biggest factor that all terms of an expression have in common. So let's say, for instance, we had the numbers 6 and we had the number 12. Well, I would list out those factor pairs. So again, using what we had before, 1 times 6 equals 6, and 2 times 3 equals 6. Then for 12, I'd list out and I'd say, okay, 1 times 12 equals 6, 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. So when we're looking for the greatest common factor, we're looking for the largest factor that's in both lists. So a great place to start would just be looking right here and seeing, all right, we've got 6 in both lists. So that would be the greatest common factor that they both have, the biggest number that goes into both of them. You'll also see later on with greatest common factor about how variables work into this as well, and all of that. And so we will discuss that more in a further lesson. But if you have any additional questions at this point about those three terms, please let me know.